All right, welcome back. Today we're going to be working on 9.3 day 1 notes, graphing quadratics. Before we go ahead and get started though, we got to talk about what is the most basic form of a graph without any transformations. Basically, without any transformations, meaning I don't move left or right at all or up and down, I start at the origin. And in this chapter, we're going to work with three parent functions. The first parent function is a plot, as the we said first. This parent function is y is equal to x squared. If I were to graph y equals x squared, my vertex would be at 0, 0. Later on, we're going to be working with square roots, so y equals just the square root of x. And finally, the absolute values y equals to x. Again, the only thing we're going to be dealing with is quadratics. So first, we're going to talk about what it means to shift. A shift is any horizontal. Horizontal is just left and right. Or vertical. And vertical is up or down. Compared to its parent function. So again, a parent function doesn't move left or right or up or down at all. It starts at 0, 0. We'll also be having a reflection over the x-axis, which is any vertical flip. Meaning the graph would be upside down. Okay. Let's go ahead and graph the parent function of the quadratic that we're going to be dealing with. Remember, my origin will be 0, 0. I'm going to go 2 smaller and 2 bigger. If you go ahead and substitute the values in for x to figure out your upper x, which is your y. So if negative 2 squared is 4, negative 1 squared is 1, 1 squared is 1, 2 squared is 4. All I do is I get those values. And again, these should mirror each other. Let's go ahead and plot the parent function. 3, 0, 0, negative 1, 1, negative 2, 4, 1, 1, and 2, 4. See, that's my parabola, which is my quadratic. Okay. All right. What we are going to need to memorize is what the parent function looks like. So I think the easiest way to memorize the pattern is to memorize the quadratic graph is to memorize the pattern. So here, starting at the origin, we're going to go right 1, up 1, come back to the origin. Right 2, up 4, because of 2 squared is 4. And then we'll continue the pattern going on the left. Okay, so again, what we're going to do is we're going to graph our transform. Here I'm going to tell you, remember the vertex is going to be negative 1 because it's the opposite of the first value. Then just put in the same value for the second. So again, 2 smaller, 2 bigger. And go ahead and substitute those values into your calculator to figure out what the y values are. Do not forget about that negative. You go ahead and just do it's negative 2, 1, 2, 1, negative 2. Again, there's a mirror of each other. So I have negative 3, negative 2, negative 2, 1, negative 1, 2, 0, 1, and 1, negative 2. Go ahead and plot those points. Alright, now again, let's see if this graph has the same pattern. I go right 1, but I go down 1 actually. I go right 2, I go down 4. So it does have the same pattern with right and then how far you go up and down. Okay? And I know it's going to go down because there's a negative in front of that. Okay? So where did I move this? I moved it. Look where the vertex was here, 0, 0. My vertex was at, I moved 1 to the left, so 1 left. How many up? 2 up. We check it out. Look at these values. I have plus 1 and positive 2. So I have 1 and 2. Let's see if there's any correlation between those two. All right, now, what is the general equation of any transform function? Well, this A right here, if that's a negative 1, it's going to be an upside down. If there's a positive 1, it's going to be a regular A facing parabola, and it's going to be facing up. This H represents the horizontal shift to the left of the east side. And this K represents the vertical shift. And again, don't forget the vertex is H and K. Now remember, with the horizontal though, it's going to be opposite. So in this case, remember we would do the opposite sign for the vertex. So since it's plus 1, plus would be to the left, because remember it's opposite. So that's why we get left 1, and then anything with K remains the same. So what we're going to do is go and give you some general functions, and I'm going to determine these shifts in the class. Is there a negative sign before a parentheses? No, so we just say no. Horizontal shift comes here, so instead of minus 3, minus is to the right. And we keep, if there's a plus 4 here, that means we go up 4. We don't ever change the sign with the K, the value outside the parentheses. And lastly, the vertex is 3, 4. Again, how do I get to 3, 4? If you picture an XY axis in your head, we go right 3 up 4 to graph 3, 4. That's when my horizontal shift is right 3 up 4. All right, number 2. Notice there's a negative sign in front. So yes, it is going to be a reflection. That means my parabola is going to be upside down. The horizontal shift comes from this value right here. Remember, it's not positive 5, it's actually negative 5. But negative, you're going to go left. It would be left 5. This will be my vertical shift. Since it's minus 7, that means that's down 7. And lastly, my vertex will be negative 5, negative 7. Alright, let's move on to 3. Notice that there's no negative sign in front, so there would not be a reflection. So you notice there's no parentheses here. There's just a plus 1. Remember, what happens inside the parentheses is the horizontal shift. You notice I could put x plus 0. So is there a vertical or horizontal shift? Nope. There's just a vertical though. What's my vertex? 0. Alright, let's go ahead and flip pages. Now, this is what I was talking about. In order to graph the quadratic where a equals 1 and negative 1, you're going to have to memorize the 5 ordered pairs or memorize the patterns. That's what I was talking about earlier. I think the easiest thing is to memorize the pattern. And then shift or reflect the points of the pattern given the equation. Alright, let's go ahead and figure out what we're going to be doing. First thing we're going to do is number 4. Is there a reflection? Hopefully you're saying no because there's no negative. Now look where the square is. Is there a parenthesis? No, because remember it's going to be x plus 0 squared minus 7. We write that way. So you clearly see there's no horizontal shift. Is there a vertical shift? Yep, it is down 3 because it's minus 3. And my vertex is 0, negative 3. Now, this table of values is for the parent. This is the original set of points. I'll go ahead and write the original set of points if you like, but I think the easiest way is to write the pattern. Here, we're going to go ahead and plot the vertex. 0, negative 3. The pattern is going to be right 1, and I go up 1 because there's no reflection. Come back to the origin. That's the origin of the vertex. Then we go right 2, up 4. 1, 2, 3, 4. I go up 4 because 2 squared is 4. Then you continue the pattern on the left. Right 1, up 1, because negative 1 squared is 1. Then right 2, up 4. And that's my quadratic. Now, if you don't remember the pattern, remember my original table that I had was 4, 1, 0, 1. So those are the points here. So here I went like negative 1, 1, negative 2, 4, 1, 4, so 1, 1, 1, 4. But again, you don't have to use this table if you just memorize the pattern. Let's go ahead and figure out the domain. First off, I got arrows on both sides, correct? So my domain is going to be all real numbers. Now my range, again, is my y. Yeah, they're both facing up. I start this point right here, 0, negative 3. I'm going to take the y value, and since they're both facing up, it's going to be greater than or equal to that y value, which is negative 3. All right, let's go ahead and do number 5. So is there a reflection? We should be saying no because there's no negative. Is there a horizontal? Yep, it is. So it's plus one. Plus one needs to be left one. And since there's no number outside the parentheses, there is no vertical shift. So my vertex is negative 1, comma, 0. Again, we'll deal with the domain and range after we plot the points. So what I'm going to do is draw my vertex. 0, comma, sorry, negative 1, comma, 0? Yes, negative 1, comma, 0. Now, since there's no reflection, I'm just going to graph my points based off my pattern. See if you remember my pattern. Right 1, up 1. Come back to the vertex. Right 2, do you remember how many are going to go up? Hopefully you're saying 4. Now you're going to continue the pattern on the left. Left 1, up 1. Come back to the vertex. Left 2, up 4. You should make sure it doesn't show the V. We will be definitely V in the videos. Now again, if you memorize the pattern, you don't need to memorize the points. It's one or the other. Alright, so the domain, I got there both sides, and the domain is all real numbers. Now my range, this point right here is negative 1, comma 0. Remember it's X and Y. Since they're both facing up and I physically touch 0, it's going to be Y is greater than or equal to 0. Now if they were facing down, that would be going to be less than or equal to. Since it's facing up, it's going to be greater than or equal to. Alright, let's put everything together and do the last question. So is there a reflection? Yes, there is, because there's a negative sign right there. So my parabola is actually going to go down. The only difference is instead of going right 1 up 1, I'm going to go right 1 down 1. The horizontal shift is right here, plus 3, but remember it's opposite, so it's going to be left 3. And this number right here is my vertical, which is up 8. Put it all together, what's my vertex? It would be left 3, which is negative 3, up 8, so negative 3, comma 8. I'm going to go ahead and fill in the domain later. So here I go negative 3, up 8. I'm just going to plot my points based on the pattern. Remember, my pattern is normally right 1, up 1, but since there's a reflection, I'm going to go right 1, down 1. Return to the vertex. Right 2, how many we do go down? 4. 1, 2, 3, 4. Come back to the vertex. Now we go left 1, down 1. Come back to the vertex. Left 2, down 4. And there's my parabola. Alright, domain and range. Well, I got arrows on both sides. Probably asking yourself, is your domain always all real numbers? Yes. Anytime you're dealing with the quadratics, you're always going to have arrows on the domain will be all numbers. Now my range, since it's going down, it's going to be a less than or equal to this point here is negative 3, comma 8. Since the range is the y, I'm going to be taking the 8. It's going to be less than or equal to. Alright, please go ahead and stop the video and to complete the homework assignment.